which process in the heart we are registering by measuring ECG. So what's the mechanism of ECG registration? What do we register by 3 electrodes or other electrodes?
Contractions.
Electrodes. What do we register? How we may know from the surface of the body what happens in the heart. So what's the nature of this mechanism of this method, ECG? What we are registering from the surface of the body? Huh? Electrical current? Huh? What? What? Electrical, what electrical? Diopter.
Activity of the heart.
Yes, electrical activity. That's important to know that we register only electrical activity. Is it possible to know about the contractile function, about the mechanical contraction of the heart by ECG registration? No. We never register mechanical contraction of the heart. By registering ECG, we only register electrical activity. That's first, what you should remember. And if we want to know about the contractility of different muscle places of heart, about different muscle parts of the heart. And if we want to know how they are contracting, mechanically changing their shape, we should make other types of investigation, other methods. We should use other methods, not ECG, but which ones? Which methods show us which? Cardiomyogram. What's cardiomyogram? There are different electrocardiogram. There are different cardiograms, cardiographic methods. Each method, cardiographic method, that's the registration of cardiac function, of cardiac process. And there are different cardiographic methods. Electrocardiography, registering electrical process of the heart. There is a second question, how we may register electrical activity of heart, placing the electrode on the surface of the body, as far as heart inside the body. How we may register electrical activity on such large distances. If we were inserting the electrode, placing this electrode near the contractile fiber, electrically active fiber, then it were possible to register action potential of each fiber. But that's not the ECG. ECG, we use the electrodes, we place them on the surface of the body and somehow register electrical activity of heart. How we may register electrical activity on a large distance from the electrode to the heart. So what do we in fact registering under ECG method, using ECG? So what we register from heart? So we put the electrodes on the surface of the body, heart inside the thorax. What's the mechanism of information passage from the heart to the electrodes and then visualization of these waves, P, Q, R, S, T? Potential, to register action potential, we should place the electrode just in close to membrane, or even inside the cell. Then we will register intracellular action potential, and we will find if we were registering intracellular, then we were able to have the picture of membrane potential as we usually show action potential of contractile cell. But we register somehow only such waves like P, QRS, T, and they show us somehow electrical activity of heart. Are these waves action potentials?
Yeah. Electrical. It is, right? Because
But it's
excitations-
electrical activity action potential. So it should be action potential,
Yes.
but it's looking different.
Just
Completely different from
excitation.
action potential. Action potential, that's depolarization, partial repolarization, plateau phase, and then repolarization, total repolarization. It's different. In C-nitrile node, non-typical myocardial cell, also different action potential. Another one, another type, there is slow diastolic repolarization, then repolarization, repolarization, then again slow diastolic repolarization. Another one. It's not the action potential, but it's showing electrical activity. Huh? Excitability? No. No, excitability, that's not a graph. Excitability. So, what's the reason, what's the mechanism of electroencephalography? We spoke already about electroencephalography. What's the mechanism? What's the nature of the method of EEG? Electroencephalography. What, in fact, we register by placing electrodes on the skull, on the head. Also, we register brain inside the skull, but we put the electrodes, place the electrodes on the surface of the head, and register somehow electrical activity of the brain. Of our brain in another place, not on the surface of the skull. So, how we register EEG? What's the mechanism of the method of EEG? Electromyography, you may remember from the first dialogue, that's first. Second lesson, or third lesson, yeah? Practical work, we wrote electromyography. The same situation, we place the electrodes on the surface of the body, on the arm, or on the leg. It depends on which muscles we want to register electrical activity. And then we register electromyogram, electrical activity of the fibers of the myofibrils, skeletal muscles.
Contractions.
So what's the nature of EMG, electromyography? The same mechanism of the method. All these methods, electrographical registration of electrical activity, all these methods, EEG, EMG, ECG,
Contracting
they
muscles.
based
What's a
on the
contracting muscle?
registration of which process, which accompanying electrical depolarization. So what accompanies electrical depolarization? Electrical activity of each fiber, each excitable cell.
Contractions.
Each depolarization is based on the movements of charged particles. There should be movements of charged particles. Sodium inside, influx, potassium outflux. Still remember? Depolarization, that's inside the cell, positive ion. Repolarization, that's outside, efflux from the cell of positive ions, potassium. So, there are movements of charged ions. Each time, as far as when charged ion moves in the space, in everywhere, always it's emitting, it's giving electromagnetic field. And this emission of electromagnetic field we may register. And we're registering this emission of electromagnetic field, which being emitted due to movements of charged ions. So we're registering from the surface of the body electromagnetic field, which we always emitting. We have two sources of electromagnetic field in our body. First, that's electrical activity of the cells, of each cell which is excitable. As far as as far as membrane changes its potential, there is influx or outflux of charged ions. Always delta, when membrane potential changes, delta phi, always there will be emission of electromagnetic field. So under depolarization of each cell of the heart, all of them emitting electromagnetic field. And we register these waves, P, Q, R, S, T. That's overall electrical emission of electromagnetic field due to depolarization of all the cells of the heart. So that's not direct membrane potential, action potential. That's not direct registration of action potential of all the cells. But that's overall electromagnetic field which being emitted with all the cells being depolarized. That means that if lesser amount of the cells would be depolarized, that means that emission of electromagnetic field would be lesser and amplitude of the waves would be decreased. And vice versa. If more cell being depolarized, then voltage, amplitude of the waves, PQRST, would be enlarged. So there is electrical axis of the heart. Think now, what's electrical axis